Okay, just to make the question clear, I'm going to Google again. Number of residues per turn alpha helix. Number of residue, 3.6 per turn. Okay, there should be 3.6 per residue in alpha helix.
It's really confusing. Is it 2? You said 2.
Yeah. So the hydrogen bond should only between the peptide bond residue, the atoms. Yeah. So let me see window.
I just I don't know if it's like a fishy intention.
Yeah, so all those atoms showing, all those atoms showing here are the peptide, the main chain. There's no side chain, so all those hydrogen bonds are between the main chain. So. So averaging 3. So if 3.6 per turn, that means in 2 turns you should see 7. Yeah, if you see less than 7, then you have 2 turns you should see 7 hydrogen bonds between and 7 residues.
Okay, so now we got that. Did this last word? Or right here, I can't.
That's right.
How you know? Let me see. Or that yellow.
This is your right.
Okay, so it makes 7. He said something. He spiraled it.
If you grab on it, your thumb goes to the direction you are grabbing.
That's one.
That's the left hand. Yeah. Right, that makes left is for comparison. For the left hand, right hand, in fact, you can't just see, it doesn't matter how you look at it. So, oh, yeah. So, this is the left hand, the only way to make the left hand I mean, no matter how you look at the left hand, this is your right hand, this is the left. I mean, the right hand is always right hand. So, yeah. That's the left. I'll put the residue on the heading.
On the left?
On the right.
This one.
Yeah, first put the residue. That's right. Yeah. Yeah.
So draw 7 like this. I mean, I just put dot. that was
Yeah,
like
how many dots you put?
it was like they were all but it kept breaking.
Okay.
So like each turn, it was like it felt like it was like going together.
This is like too many here.
Oh wait, 1, 2, 3. Next one, 1, 2, 3.
Yeah. Each turn is 3.6.
Got it. So instead of like 1, 2, 3,
Yeah.
and then the next time we got it.
Right. So you should be standing. Okay, let's see. Are we learning enough from this Play-Doh? We can move on to the next one. Okay, is everyone happy with what we got with the Play-Doh? Make sure you know what's right.
Wait,
Hydrogen bond should be okay, so the hydrogen bond is formed between 1, 2, 3. Yeah, so 1, 2. There must be a back. So between chains, those are the peptide bond atoms. Yeah. Blue is nitrogen. Yeah. Red is oxygen.
so how many nitrogens are
How many there is one amine, only one amine group in each residue, so it should be 3.6 per spiral per turn. Yeah, nitrogen atom. Nitrogen atom, 3.6 nitrogen atoms per turn.
It's also 3.6 hydrogen.
No, hydrogen there are too many. It's yeah, there are too many hydrogen. It's hard to count them. Okay, now if you are done with this, we have another exercise. So you may want to separate the color. Make sure the color is not separate. So do a chain of Play-Doh with the first structure. So there'll be 3 exons and the introns in between them. So use you use different color, make this one. What? No, just do a chain. Just do a chain. So there should be 3 exons. That means 2 intron and 2 untranslated region. This is your pre-RNA. How many introns? 2 introns and 2 untranslated region.
You want 3?
Well, yes, look at this one.
So not.
The brown are exons. 1, 2, 3. 3 exons. How many introns? 1, 2, 2 introns. Oh, you don't have to call this one intron. This is actually kind of an untranslated region, UTR.
Okay.
So that's. I guess the textbook call this intron, but it technically is called 3' untranslated region, 3' UTR. Yeah, see, it goes here. If it's intron, it will be removed, but it's not removed, so this one shouldn't be called intron. Yeah. So hold on, let me see. I'm sorry, I lost the slide. Where did that slide go? Okay. Oh, here. Sorry. Okay, so see, those introns here, these 2 introns are removed. So I would call that to an intron, but this one is not removed. This really, I would think the textbook had a mistake here. So this part shouldn't be called intron. Yeah, because it's in the final mRNA, in the mature mRNA, so it's not removed. Yeah, it shouldn't be called intron.
Okay, so 2 introns.
Yeah, only 2 intron, and those should be UTR. Yeah. Yeah. So this part is actually still here. Only 2 are removed. That's really the point. Yeah. So. Yeah. Do first step, then second step. Yeah. Now, before you do that, you should also mark the starting ATG position. Where is your ATG and where is your stop codon? You use the pen or whatever mark on that chain. Where is your ATG? Where is your stop codon? Yes. Where is your ATG? That's correct. For mRNA, thank you. That's a good question. It should be AUG. This is the mRNA. Yeah, it should be where is your AUG codon? Where is your stop codon?
Yes.
Okay, so okay, make a this will be a pre-mRNA, and then label AUG plus stop codon. All right, so that's the first thing we do, and the next step. Oh, the next step is actually add poly A. This is for eukaryotic. You can actually add some poly A to. Yeah. So, I mean, you can do that, but then we do the. But wait, let's just do mature mRNA. Mature mRNA. Yeah. So. And also label the position. Where do you think the promoter is? What do you mean beginning?
The blue is in the front, yeah, the concept.
The blue one? Why don't you label it on the Play-Doh you are making, and that way label the promoter region as well. Label promoter region. Label also the promoter region on the chain you are making.
Yeah, so it'll get a short one. It's right after the start. That's the next step. That's the step. Okay, well, see, but this one I started.
Yeah.
We need. Let's see what we can. And then you still like. Yeah, I see things.
Yeah, I have enough to reach this time.
Sorry.
I see you.
What? What I ate? Oh, it's the road.
What is it? The one I'm what is she saying? What is that?
I have added the cat. This is like the start.
Okay.
No.
I'll check on mine. I wasn't
Hello. But anyway,
Yeah, I'm a big star.
No, that's wrong. Relabel it. This is
You want to make all three.
that was what I was like, she has
okay, everybody, where do you think the start will be? I just realized it's not clear here. What do you think the start means?
That's the
First more?
Yeah, the first one.
Would be the one.
I realize this is probably not very clear. It may mean start of transcription. Let's make sure this is the start codon. Make it clear. This is the start codon. Where is this start codon going to be on the chain? Here.
Let's say
Where?
here. So
Yeah.
the first one, no, in the right.
Where we put your start?
Okay, right, that's what I'm saying. So why not change?
They just better say, oh,
Yeah.
The first orange part is not part of that extra. It's 5 pounds.
so be like,
Be part of the extra. The stuff should be part of the extra.
And so the, like this, orange side of it is just like
3 So if you put the start product in front of extra, that will be wrong. It should be the very beginning of the extra. Yeah. The first thing on the extra one is to be the start So if you say money is in front of okay, listen to clear at least some misunderstanding. So the start and stop product must be extra. It cannot be in front.
So then last year,
Yeah, that's a promoter region. There's actually also some regions. In reality, there are also some secrets needed for ribosome to recognize startup translation. So that probably containing this origin part should contain all those translation initiation signals. What is the name of the translation ribosomal binding site in program?
Oh, that's a eukaryote?
That's how you let go. There are translation that's called transcription. Criminal box, under 35, that's called transcription. I'm asking the signal called translation. Yeah. Okay, everyone, what is the signal for prokaryotic translation signal? What ribosomal binding site?
Oh, and prokaryotes?
Yeah.
There is one, and then they do it together, transcription and translation. In prokaryotes. Isn't it a two-step process?
No. Let me give you a hint. That thing shines.
wait, shine?
Yeah.
Everybody says one.
No, but this is the other Google. Why don't you use the smartphone and the computer? Yeah, I'm giving you a hint and say the ribosome recognition signal shines. That's actually a very good hint. If you Google, you will find it. Usually you will find it. The translation initiation signal on RNA in prokaryote. In bacteria.
Shine down.
That's it. It's called shine diagonal sequences. Wait a minute, you just finished those online quizzes. You don't remember?
It's
not in the test.
It's shine down.
Yeah, shine diagonal sequences. Okay, someone remember at least. Okay, good. Let me see what whoops.
I don't know which you bring her up.
Oops. Okay. Okay. I think we finished the Play-Doh one. Let's separate the color and put them back.
After all of this, wait,
Okay. If you want to, let me at least take some picture of your work, and then you can put it back. Okay, who is ready? You can put your name. You can write your name if you want. If you want to put it up.
It is working. Thank you.
It's a skinny card. Okay, so this one should be.
So y'all is difficult.
Sorry, hold on. That's not. Well, that's it.
Okay.
Oh, yeah.
Yeah.
I guess. Okay. I said we had to get there. No, he was there. I said
I did not make that key. I did not do it. Get a couple of medallions. Is it I think that's the thing. No. Consider that you do this for it's cool.
It's actually very important to see this one is clearly this one, we always people very great.
I see that like a shirt with the green and white.
You can't write the name on a piece of paper and That's why I take the picture and see it.
Oh yeah, I guess I'm telling you the start they have from
Right on the end of the
Oh.
Oh.
We didn't take all of it.
What? Yeah.
rather than my name and you can leave that food right today.
You can't write it.
Yeah, sweet. We're ready.
Listen, probably all the different colors.
Yeah, let's start getting ready. Yes, they were actually having shitty
What's the time? Do you do the second one? The first one.
I didn't do the first one. I did the first one, I just like when you the second one was the last one is 1, 2, 3, so like all the braided together, and then the third codon and poly tail and then cap. Yeah.
So the exon.
Just that fun, no just first.
And then the
Codon, then start codon, and then the cap, the five cap, and then poly.
That's the easiest way to start.
So you start.
Alright.
Wait, there's one more.
Oh.
Wait, we're not ready. But then you want to stop.
Yeah, we are. Alright, almost ready.
Okay, for those who have
Ready,
finish the Play-Doh, there's more exercise.
With the Play-Doh?
No, not with the Play-Doh. Oh,
You can use this ball.
I'm trying to go teach them.
you have to someone to do that angle.
That is some nice handwriting. You a little scrub.
You got snakes
Okay, something like that.
Okay, let me see what, oh, I see. I need to start my Socratic room for you to actually vote for this. Socratic. Wait a minute. That's not Socratic.
See, you too.
That's what I'm saying. Y'all gonna put it back in the color. But that you can go use it with Play-Doh and you see like 7 different colors on the wrong color. I was ready to fight there.
Oh, yeah.
Okay, so I have studied the Socratic. Oh, well, yeah. So the question is this: if a gene have 4 exons, any of 3 exons can be returned in its mRNA. How many different mRNAs can this gene generate? How many different splicing isomers can it? Oh, I just realized you can actually use Play-Doh to figure out this question. you can do this just by thinking. Okay. Yeah. So a gene have 4 exons. Any of the 3 exons can form an mRNA. And how many different mRNA? How many different splicing isoforms can this gene generate? There's a vote. So A, B, C, D. There's a voting here. So you can vote on the Socratic if you like.
Are you taking a picture of it on your iPad?
Yes. Wait. Okay.
Well, I use Sharpie, so.
It ain't real.
Yeah.
He takes a bus up.
What if I want to?
Last name, you know, his name, Dr. Chance. No.
Oh. Yeah, it's not.
I'm gonna write this down. Yes. I have not started application. Yeah, all right.
See, that's why I like, it's already active.
I asked this one person, I said, hey, you not these 2 hours.
She's trying to graduate.
Yeah. They don't start until yesterday. And then I'm trying to do this thing tonight.
Wait, what does it do?
I have to go to this.
I'm trying to, that's what I'm trying to do that. This is simple.
It doesn't even, it looks like you don't even have to sign in. Yeah.
And this is your name.
Yeah, my Socratic real name is basically my name. Full.
Yeah. Is it capitalized?
It doesn't matter.
Oh.
Yeah, I was told it's not case sensitive. Okay, let me see the survey. Oh, many of you vote. Let me see. B is 4. D is 6. Okay, so how we do this? So you can try this one out. So yes. What?
Don't worry, keep it going.
Oh. So you we have 1, 2, 3, 4. 1, 2, 3, 4, and you want pick any of the 3 will work. So if you pick 1, 2, 3, this one will work. If I pick 1, 2, 4, this one also work. So I pick 1, 2, and then it 1, 2. 1, 2, 4, 1, 3, 4. This also work, right? So it looks like I have exhausted my choice starting with 1. So I'm going to start with 2. If I pick 2, well, it has to be 2, 3, 4. There's no other choice, right? And if I pick 3, I already picked the 1, 2. So it looks like what?
4, 3, 4.
Okay. Yeah, so basically that's all you can come up with. Yeah. In fact, this is if you pick any 3 work, basically you have to leave 1 out. And how many And so basically, this is something called 3 out of 4. It should be just 4 actually. There's only 4 choice to pick 3 out of 4. That's actually basically this is. Yeah.
So in this instance, they can't be switched around.
Yeah, like why is it order?
Oh, that's right. Yeah. Because the exon are not moving around. Right?
Okay, so this
Yeah.
You gotta keep 1 and 4 at the same spot?
No, the order, the 1 always in front of 2, 3, 4.
Oh, I see.
Yeah. The exon is not moving around. Yeah. That's right. Yeah. So, yeah. So, yeah. Well, in a way, it's kind of hidden when I said this is the exon. Right? With the exon, when it's the spliced from pre-RNA to RNA, you don't
switch them around.
Right? Yeah, you don't switch them around. Yeah.
So if you understand.
Yeah. So we have 1, 2, 3, but there's not going to be 3 to 1 or 1, 3, 2. Right.
You can take a 4 out, use a 3 out, you can do that. You just put it out.
That's right. Yeah. So if you pick 3, you have to leave 1 out. There are only 4 numbers. You can only leave 4 single out. Yeah, that's 4. Yeah, that's another way to do this. Yeah. Okay. Now, if I change this one, say if any 2 of them work, what the answer will be? Yeah. If I change the question, say instead of any 3, I say any 2. Well, what would the answer be? Yeah. What's your okay? You can still vote again. Let's see. Majority, almost half of the class voted for 4 in the previous one. If I change this one to any 2 exon of them can be returned, and then how many different mRNA can this gene generate? So basically you have to. So you have 4. You have 4. You have to pick 2 out of 4. What's this number? 6. How do you get this one? It should be basically 3 times 4 divided by 2.
Oh, I definitely do that.
Okay.
Are we answering this question on side?
Yeah. Oh. It's C. D is correct. Yeah. So well, obviously. Yeah. Okay.
It said it's waiting.
Oh, really?
I'm confused.
Oh, hold on. Let me see. Okay, I just started another question. This one is just A and B. Which sequence can form a hairpin? Yeah, what a hairpin is basically yeah. So
Isn't what?
Wait, mine shows A, B, C.
yeah, but there's only 2 choices. I pick either A or B. Yeah, by default they give you 5 choices, but pick either A or B. But you can actually work out solve this problem using the sheet I provided. This sheet actually can be used to solve the problem. So we can solve this problem.
So you want to start right now?
To show them.
Yes, yeah, but this sheet is not for you to actually draw the hairpin. It's something called dot plot.
Dot plot?
This is called what? So what is a dot plot? Okay, oops, no. So what's the requirement to form a hairpin? What? Yeah, but what do you mean binding between the nucleotide? They have to form base pair, right? So they have to complementary, but you have only one sequence, right? So somehow the sequence had to form complementary sequence among itself, right? So, what's probably should write the sequence somewhere. Hold on, let me put aside. So I have a, let me see. So I have a, say, whoops, there's no color. Huh? Why is there no color? Okay, let me see. Ah, finally. Okay, so we have A. So let's look at the first sequence. A, G, A, T. Oops, no. T, T, A, C. So, and I'm going to also, so basically I want to see whether this sequence can form base pair among itself. So I will do part of this and then you can finish the rest of it. So this dot plot, basically you're going to see which part of the sequence can form base pair. And so let's first look at the A and A. Will A and A form base pair? No. So we are going to list the A. So first A and G, no. A and T, will this one form base pair? Yes, then we put a dot here. Okay, A and T, also one. Okay, so G, and then for there's a base pair here. Again, A, no. T will form base pair with A. Again, T. A again from T. C will form base pair with G. That's it. So, and you should finish the rest of it. If a sequence indeed form a hairpin, form a long enough base pair among itself, what kind of a line should you see? If you indeed see a sequence form a hairpin, you should see a straight line somewhere, but it should be along the, since the sequence, it should be, I think the diagonal should be this. Yes. Yeah, it should be along this diagonal. I don't see it here, so this sequence itself won't. it's not sufficient. Okay, so and oops, and this is the sequence. Let me also do this exercise. Where's the picture? So you want to put the sequence. Right. Draw a cross diagonal. Actually, I forgot which one is the correct answer. So I also need to figure out this one. Yeah. You really need glasses.
I know.
Yeah. So G A T T A C G.
Oh, you meant just right? You know how to make a whole document.
Are you trying to make?
Just wrote down the same thing.
Like the intersection, so like
Yeah. So you just put dots with the T's. Yeah.
Oh, I'm gonna look at my top row.
That's what.
I think you mentioned like A goes to T.
Well, it has to be opposite, right? It's not like
T there.
It's like that. Because I really want to read the material. Reading residential.
Yeah. You got a hairpin?
Yeah.
Which sequence you gonna happen?
It's D, you know. And the only one that has asymmetry things.
Exactly. So it's not A. Alright.
Alright, well, definitely.
I go backwards.
You didn't matter as long as
So you do
5, starting with 5
in a situation.
You're so smart.
Real smart.
That's not So you did this.
literally copied that.
Okay.
Right here. I'm right. Each box.
Mm-hmm.
The whole thing isn't supposed to be a diagonal. It's just
No, just a long, certain portion. If it's longer enough, you can tell. Have you found it?
Yeah, so this way.
You found it?
Those of you both paid, so like they should have been here and they should have been there. And that's
Which one?
because this part ends with the
Oh,
backwards part.
excellent. So you should. So if you found here, you should also at the bottom.
Oh, okay.
Yeah. If you found it,
Oh, I
actually you should find the two regions because it's the same sequence. If one region pair with another, the other part should pair with the first one. You should actually see two sections of straight line. So yeah. But it's good if you see it here.
Is
You
it
should
this
also.
one?
Yeah, this one should also.
Is this one?
No, it should be this one.
It's always this way.
Yeah, because it's this way. Yeah, because this is self-pairing, so it means the direction has to switch. It has to go backward.
So it needs to go that way.
Right, yeah. So yeah, if you think of the first the sequence is going to go from going to go from 5' end to 3' end, right? So this is the sequence. If say a region has to form a base pair, it has to loop back, right? So if we loop back this sequence, and then if we loop back sequence, there are base pairing here. Right, let's say this one is 1, 2, 3, 4. Let's say 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then this will be say 21, 22, 23, 24, 25, 26. So on this region will be 5 to 10. The other region will be actually 26, 20. Should be so the two regions cannot go from one direction. It has to be reverse direction, right? Because the sequence DNA base pairing has to be in reverse complementary. So it cannot go. If you see a line goes in one direction, that cannot be right for the hairpin structure.
Or goes in the opposite.
Right, it has to be go to the opposite direction. Because the DNA base pairing, the DNA double helix always say one is 5, the other one is 3. Then the opposite one has to be in the reverse direction. Yeah, you can if you have both of them 5 to 5, that cannot form a base pair helix.
Oh, I get what you're saying.
Yeah.
Okay.
So, but this one is a single strand form a helix among itself. So the two regions cannot go in the same direction. It has to be in reverse direction.
Right. Wait,
Yeah.
can you repeat that? Right.
Okay, that's me. You seem to understand. Can you repeat what? I'll re-explain what I just said.
What part don't you? What part do you need? The reverse part or the 5 to 3 part?
What is the 5 to 3?
The 5 and 3 is like going from the beginning. So when you look at the other DNA, you see one goes from 5 to 3, but to actually have a bond, the other one has to go the opposite way. So we're just looking at one strand of DNA like we are here. To have a bond, to have a bond, and one end has to be going the opposite way.
Okay. And then the other part.
Yeah, they were connected. So
And basically on the graph, how it's going to look like.
Put on the graph, or is that?
your slope, you should have a positive slope, a positive correlation.
Sorry. I see. Okay, you're doing.
So like, where is this? Like, this is what
That's
I.
okay. You should also.
No, keep it
I see. I didn't
Okay,
see
I'll
it.
be
Sorry about it.
Yeah.
Sorry about it. I didn't give you-
What you telling me? Turn it around.
Right.
If you can, just tell where it is based there. Yeah, you don't have to. But this is basically how computer found out. How do you, why do we think the input sequence? I mean, this is now it's very short. If you think about how do people find out in a human genome which part match with There are some methods to do this automatically. This is actually one of the most, I guess, primitive methods to find the internal structure. But others are similar with that. So I mean, it's cumbersome for you to do this on paper, but how computer does this is actually very, very efficient. So you should see a diagonal, two diagonal lines.
Right here.
Yeah, if you see it here, it should also be.
Oh, you mean two?
Right.
Okay, I thought you meant one.
Oh, no.
Okay.
So this works. Yeah. So that works. Yeah. You should be that.
Okay, that's. My bag goes right here.
Yeah, that's the first thing. Yeah. That's why you sign your name on it, Don. Actually, you sign your name on this. Oh, gee, what time is it?
3:42.
Okay, all right, yeah. I guess this one, which one take a lot of time? I forgot, but it seems like the Play-Doh take a lot of time just because I have to take a picture. But this one, I guess, is faster. Okay, actually, let me see. Yeah, there are some other things. Remember, let's do the piano. You really need to know what's the anti-codon or the codon, but let's do this next time. We also need to summarize the central dogma.
So we're gonna do that next class?
Yeah. You need to understand central dogma to actually.
Oh, you mean like genes, mRNA, mRNA to protein?
Right, yeah. Bacteria and eukaryotes, what's the main difference?
Right.
Yeah. Okay, thank you very much.
I have a question about the two diagonal lines you're talking about. With this line, the second line.
Right, if you find a line here, that means this region might be different. But then this region also is symmetrical. It should be symmetrical.
Okay.
Along that.
Oh, right. I see what you're saying.
Right. It should. If you found diagonal here, there must be a diagonal. Okay. Oh, make sure your name is signed on it. Yeah.
You are, right? I'm going to that one.
Oh, okay. Hey, I guess I need the back and the Play-Doh.
All right. You weren't ready for that one.
I wasn't ready, you're right.
I clearly see that.
I don't walk out of here again. Dr. Can I always do that? I don't think I don't participate, but I really always.
Oh,
I always take
you
the papers
mean
home.
you actually will.
I always take it home and then we get back and you're passing them back. And I'm like, it was in my folder.
Oh, okay. Sorry.
It's there.
Yeah. Okay.
I'm over here doing what I need to do.
Okay.
It's a line.
Is it
Oh,
really? Here.
And we're not on my birthday. So I know you remember.
I'm basically counting the.
I don't ever call you
Yeah,
like
sorry,
that.
I'm not.
Who's the one that's,
I will give you that back.
okay, I'm not saying that, I don't think you,
Okay, I don't need all my Play-Doh back.
as far as. Why do you not gonna do that? Alright, that's right. We got this.
The class was very fast when people working on Play-Doh.
Goodbye, everybody.
Bye.
Oh, hello.